Right. Hello, everyone. My name is Dushyant Priyadarshee, and I'm going to speak a lot, well, a bit actually, not a lot, about Azure Functions and the security around it. My camera is here. My screen is on this side, so I'll probably look away most of the talk while I'm presenting. Um, I work for a company called NewDay, and this is part of the presentation because this is where we'll understand why the things we are doing and the way we are doing. NewDay, in case people do not know, it is a credit card financial company, and uh, so we essentially make credit cards and lend to people. So one of the aims of the company is to help people be better with credit. So we do provide services on how to build good credit to people who may not have good credit or who are struggling with credit as well as helping people who already have good credit. Like you can see on the slide, there are some big names who are our retail partners. And I recently joined the company, so I honestly had no idea like Argos or Debenhams were using NewDay cards. So those are news to me, but now I know. Also, we do provide our own cards like Aqua, Opus, Fluid, and Marbles. Those are specific to NewDay credit cards. It is a profitable company and it's quite big. Again, like after joining the company, I figured out a lot about this, about NewDay, about what it does and how it does it. So I'm part of the platform team at NewDay, and uh, obviously it is a financial company, so we have to be compliant with the payment card industry, DSS, the data security standard. So security is very important. We currently use at least 30, quite a lot more actually. In the last few months, we've added a few more, but at least 30 Azure services, and the whole product will be an integration of multiple Azure services working together. We have serverless microservices architecture on a public cloud and we are writing PCI DSS compliant software. Along with that, we are a financial company. So I hope you understand security is very important for the overall system. And a majority of the responsibility for security, although we do have security teams, we have security testing, but majority of the security responsibility does lie with the platform team, which I'm part of. So as I'm told, roughly 3 years ago, NewDay by itself did not have any in-house development. So within the last 3 years, the whole platform has been defined and developed within NewDay, hiring like development teams. So meaning all our technology, which is Azure-based, is cutting edge. Like it is the latest. Like most of our source code is netcode 3.1, which are moving towards .NET Core 5. We use Azure, we use Terraform, we use like all the latest Azure services like Data Factory. We are also using, looking to use app service environment and many other features that are coming on Azure. So while I'm explaining this, I'm saying that the security is very important in the overall ecosystem of our systems. So now going into now that we understand, it is a serverless architecture we have throughout our system. We use Azure Functions heavily. Many and most of our systems are reliant on Azure Functions, meaning the platform team will be helping developers design secure Azure Functions. And one of the things we are concerned, and we are rightly concerned, as well as we make sure that we understand, is who is triggering your Azure function. So obviously, most of you already know about Azure AD-based authentication and authorization of who can trigger Azure function. Also, you could be doing something like app gateway, API management, and many other VNet integration to reduce access to your function. But one of the simple things that we do in my team and in NewDay as a whole is network access restrictions, which I will go into the portal and show a bit so that it's easier to understand. Before I do that, so this is straight from Microsoft's documentation, the screenshot. And if you see the access restriction rules, which are the IP restrictions or reducing the access to your function, is available from consumption plan itself. but other features are available as you get a better plan, like premium, dedicated, or something else. So what I'm saying here is, in a bid to bring the cost down, we do almost all our development in consumption plans. But going forward, there is sometimes a need, we will have to get a different plan. But from development phase itself, we can introduce IP restrictions. If we go ahead, even with consumption plan, we can still do IP restrictions. And that's the motivation behind this whole idea of applying IP restrictions from the development environment itself. So now just do a quick demo to show what I'm talking about. So hopefully it will make a bit more sense. It does get a bit complicated, so feel free to ask me questions in case I'm not explaining properly. So I have got, this is my personal Azure subscription, and I've got few deployments here, Azure Functions. So like this function, for example, I'm calling it resource ID 522. So the way to add network restriction is I go to networking. I hope you can see it. Let's zoom in a little bit in case. So I'm just scrolling down to networking. This one here, access restrictions. And in here, this is where we can say who can access this function, essentially who can trigger this function. So maybe we have, say, an internal system. Let's say an internal system 1, and the priority, lower the priority, the higher the rule, the sooner the rule will be applied. So let's say 300. And let's say 192.65.78.65. And you should normally be providing a CIDR range. I'm not going to cover what CIDR range is, but I'll share some information later on how to understand in case you do not know. You probably already know this. But essentially, this one here is saying only this IP, but I could be doing it 30. That means it becomes a range. A range of, in this case, it will be, well, I have to calculate. I can't type now, but it will be multiple numbers, multiple IPs that will be allowed in this case. But in this case, I'm saying 32, say. So once I've applied this rule, I cannot access this function. So now if I did go back to here and try to trigger it, well, I'm going to the URL, which will be same as triggering it. I'll be getting a forbidden error because obviously we said only that network IP can access that function. If I remove this, obviously I can go ahead and access it. Should take a few seconds, and it does take a few seconds to get back. But I hope this makes the theory or the basic of what I'm saying. Okay, so I went to do in private because it takes, I think it's cached in my browser. But anyway, so now I can access the function. So this is the way of restricting who can trigger your function. And with that clear, let's get into a bit more detail. So the issue at hand we have is, let's say we already have an Azure function and we're calling it function A. And then maybe we have two internal systems, could be testing, could be something else, and they need to trigger function A. So what happens is this function A in its rules needs to add these two IPs saying, okay, I will allow them to trigger me. But then what happens when in our ecosystem we create a new function, and this function B, let's say it wants to trigger function A. And when it tries that, it cannot, because function A doesn't have the IPs of function B. So that's one of the issues we have when we do apply the IP restriction rules. Yeah, so that's the beginning of the problems. I'll add more to it. Scaling. So this again is screenshot straight from Microsoft's documentation. And it's saying that a new range of outbound IP addresses may be assigned. That is, if you scale a function, your IPs will change. It's very likely it will change. Again, in the same documentation, Microsoft says for the setup where you have IP restrictions, it is recommended, or Microsoft are okay with it, if you add the whole of the data center of the Azure region in your IP list. That, in theory, can work. But the thing is, that IP you could be sharing with any other company, consumer, or user. So let's say 10.0.0.1 is an IP for my function, but because range, somebody else's function can also have the same IP. It's the probability of them triggering your function is very low, but it doesn't take it away. They could still do it in a very lucky way if they had that luck. But even then, we would still want to go towards least privilege policy. So we would not do that. We would not do the adding the whole of outbound IP ranges, but this is a problem. So just to explain what exactly I'm talking about here is, say in our system now we have function A and function B. Function A is allowing internal systems, these two IPs, as well as it's allowing function B's IPs, saying function B can trigger function A. But maybe function B is seeing a lot more traffic, so we want to scale it. So what happens when we scale it? The IP address of function B changes, meaning function A will no more allow function B to trigger it. So this is the main issue we are trying to solve here at NewDay. So we want functions to have these restrictions, but we also want to make sure they can interact with each other with least management from users or human beings. So the simplest solution that we think can work in this case is this. So if we have a function here with internal systems allowed in, and a new function comes in, we want an automated system which will automatically allow existing IPs, which we know about. This could be like a static list somewhere, and they will be automatically allowed in function B. And if you see, these arrows are both ways, meaning function A will allow function B, and function B will allow function A. And the same way function C comes in, it does the same thing. It starts allowing everyone, including the internal systems. It is a dumb solution, but it's almost like having a class with lots of public methods who can call each other, which is what this solution is. But this is like the basic solution which can work with the least management from users and human beings. So we don't have to change any IPs on any of these when any of them get scaled. And on top of that, there is another small issue, which I touched on roughly, is that the function IPs are not single IPs, they're all ranges. So each function can have a possible outbound range and possible inbound range as well. So these are outbound ranges, but there will be inbound range as well. Inbound are normally 1 or 2. In this case, inbound range is 1. I will show how to get these values as well. Maybe I can just show it around now. So the way to do that is on Graph Explorer. If I look for function app and I go into details, I'm going to copy this so that's easier to see. So this is VS Code, and if you see, this is the possible outbound ranges. So the function, in this case, the name of the function is resource ID 522, has got a range of IP addresses that it could be trying to trigger, or that's essentially the host for the function. It could be any of them. So we would allow only these specific IPs on the list of rules when we apply them. Anyway, so that's roughly what the issue is, what the rough solution we think is going to work. So let's say what we need. So first of all, we obviously need some kind of logic somewhere which will do all the work, and it can apply the changes onto Azure. And the other system that we do need, that logic needs to know when to allow, when a new function is created or when something is scaled, it needs to figure that out. And also, it needs to find out what to allow. It needs to figure out what are the range of IPs, what IPs to allow and what IPs not to allow. So it overall needs a system with all these different features or different modules, if you like. So at NewDay, from this idea, we went ahead and selected 3 technologies: Azure Event Grid, Resource Graph, and Azure Function. So let me just quickly go into a bit of intro into the 3 technologies, which should make it clear as to why we chose them. First is Azure Event Grid. So Event Grid is a system on Microsoft Azure, which generates events from multiple sources. So these on the left are event sources. And the bit here, the curly brace here, that effectively is a topic. So for example here, the event source blob storage can have a blob storage topic. And think of it, if you see analogy, for example, think of it like sports as a topic. So when you have sports as a topic, then all sports information comes to that topic. But when you subscribe to it, which is the subscription over here, you might want to filter it down to something like football, for example, or cricket, whatever you want to filter it down. So the subscription here works with the event source. And once the events come into the subscription, event topic, the subscription here filters it down and sends those events to the handlers, the event handlers. It does get a bit complicated as you go forward because as your subscription itself is an event source, but as your subscription and event grid subscription are completely different things, but it does get confusing as we carry on with this. So what I was going to explain over here is that, so if you think of it as your subscription, under Azure subscription topic, any event in your subscription, you can look at them. You can figure out whatever is going in your subscription. Well, at least the bits that Microsoft is providing, we can figure those out. And then we can filter them and we can pass to a handler, which can be an Azure function. It is quite a slide heavy talk, but we do have a few demos. So let's have a quick look at Event Grid. So again, so I've got a small script here, which is using Azure CLI. I hope it's big enough for everyone. Shout in case it's not. So the event grid here, like we discussed earlier, event grid, we're creating a system topic like in here. So all these event sources are Azure system sources. So subscription, for example, or Event Hub, resource group, they're all controlled by Microsoft or Microsoft Azure. We don't trigger those events. We just handle them when they're triggered. But we could have custom topics, and those are separate topic. We will just stick to the system topics in this talk. So it is creating a system topic, and in this resource group name, this is the name. So I should actually trigger it first. E.g. Ooh, okay. Yeah. So it needs my. So I need to pass in my subscription ID as a parameter here. This should be very quick, actually. So all this is doing is creating an event grid topic named, where's the name? Name is here. So if I go back to my portal and look for the topic, let's refresh. Refresh. Takes a few seconds. Still a few seconds. Oh, there you go. It does take a few seconds to get there. So once you have an event grid topic, so this is the topic we created, like going back to the graph, to the slide, this bit. So this is the thing we have done. So we have already said that the resource group, which is what the script was doing here. So it was saying the source of events is the subscription ID, which is what I just provided, the subscription ID. So any event in the subscription will be coming over here. But then when you subscribe, you can filter it down. So in this case, let's just call it test sub, for example. So you can obviously filter it down to whenever there is a success, a failure, or somebody cancels some operation, or a resource action. So all these things you can filter it down. And you can filter it down further on the basis of the event grid payload, event payload. So what I mean by that is, so if I go to Microsoft documentation, which I'm looking for it here. Yeah, there you go. So this is, so like you see, these are event sources. This is Microsoft documentation, event sources. These can be many event sources. The one we are looking at is the Azure subscription. So here, each subscription has specific event payload, if you like, or the event type JSON that it will provide. So this is the JSON that comes whenever an event from the subscription is triggered. And in this trigger, you can see like which resource is that which has triggered the event, for example. In this case, a storage account, something has taken place. And what has done? Event type is a resource write. And if you scroll down more within the data element, there will be operation name. And that will say clearly what has happened. So it can say a creation, a deletion, a change, a config change, or many other things. So we can see any of the operations by again looking at what Microsoft has made public. So again, in this URL with Microsoft documentation, we have the whole list of different operations that we can see and filter depending on what we want to see in the events. So going back to the event grid, in the filters, you could say data dot operation name, which is the value from here. Which is the value here, operation name. And you can just say, I'm interested only in writes. So you can say string is in write. We may be interested in delete. Then you can also say storage account delete. So all this is doing, it's a simple filter here. All it's doing is that the operation name can be write or delete, for example, in this case. And that's what it will take and trigger the function, trigger the event handler. So if we go back here again, the event handler is provided here. So we can be triggering an Azure Functions to put it in a storage queue or any of these other things we can do. So this bit is regarding creating an event grid and an event subscription. So if I just quickly see, the next one is debugging. So this is quite exciting. So when we investigate further into it, it is both exciting and it can get quite difficult because many of the things with Azure subscription system topic are not done, are still quite buggy. So Microsoft is still fixing lots of bugs around these things. But anyway, so just to quickly show you an event grid triggered function. So this is a default template. And if we wanted to trigger this locally, for example, so we'll just start debugging. It doesn't like it. So let me just. So we start debugging. I'm not sure why it does that, but sometimes it just thinks it's a class library. And have a breakpoint here. So there are two main ways of triggering. So obviously we can make it create a mocked event from Postman itself. So if you see, this is the default URL, which when you create a default from the template, when you create a function, this is the URL it will tell you. And that makes it quite easy to deal with because now you know how to trigger this function from your Postman itself. So all you have to do is go to that URL, and my function name is function1 in this case. Oh, where's good? There you go, function1 in this case. And the bits to look at here is header, obviously. And in the headers, we have to say AEG event type notification. So when a real event triggers, this value will be very different. It depends on what you are actually doing. But in our local debugging, a notification is all we need. We just want to hit the breakpoint for a local debugging. The body is the main bit here. This is the JSON file that we got from the Microsoft documentation. So the JSON payload that will come with the event grid event, that's the one we need. And once we have got that, we can just send it, and that should trigger our function, which is actually does. And from the event grid, we can actually access the data. So this is the data bit that we were looking at in the JSON. So this is not the real one. This is the mocked up event, but it gives us enough to trigger what we want and do our function based on whatever we wanted to trigger it with. but maybe we would want to trigger it straight from Azure in that case. And we can actually do that actually. But in that case, we'll have to use a tool called ngrok, which you may or may not already know. So I'm going to show this quickly. So ngrok, all this will do is, so once it runs on my machine, it will forward any request from to this URL to localhost, which is this case, my machine. So remember the event grid that we were creating earlier. So we'll go back to that event grid and we'll say endpoint is a webhook and select endpoint. So we have to paste in that. And then the other bits that we needed to do, which is essentially just copying from the function. And that just gives the whole URL to the function that to trigger. And once we confirm that and we create event grid subscription, so whenever there's an event in the subscription, that should trigger our function. This could take a few seconds, actually. It already thinks that is an event, which, because it's a subscription, and I just created event grid, I meant Azure subscription. And in the Azure subscription, I just created an event grid subscription. So that itself is an event in the Azure subscription. It does get a bit confusing because the word subscription being used so many times. This could take a few seconds. So while it's doing that, quickly check in case there are any questions. Oh, for some reason, I can't see my chat. Come on. You might have to take my word for it then. Possibly, while we're waiting for that, I could go ahead with the other demo. So I'll just leave that there and let it trigger as soon as it's ready. And yeah, so we'll see once it hits the breakpoint, because it could take up to 2-3 minutes for event grid event to be triggered. So the next bit that I wanted to touch on is the next Azure service that we chose, which is Azure Resource Graph. And there is a reason behind it as well. And let me just quickly explain that bit. So I already had Azure Resource Graph open, which we had a quick look earlier. So Azure Resource Graph gives you access to all resources or all metrics, not metrics, all properties of resources in your subscription. So you could do something as simple as count all the resources. So all you have to say is resource summarize count. And if you run that, it'll give you the count of all the resources in your Azure subscription. And you could do something a bit more interesting, that like this, where you say count only the websites. And if you just say this, it should give us all the websites in our, oh, well, type websites. But type websites can be function app as well. So maybe we're interested in function app. So we can say and kind, in this case, kind. Function app. So if I run that, that just gives us function apps. And once we get any of these, we can go ahead, like we did a bit earlier, to see the details on them. And in the properties, we can have all the details about that function app. So you can have the IP addresses, you can have a bit more like what app service plan it's hosted on, and any other properties of the function app. Oh, I'm surprised it still hasn't done it. Okay. So this is a small script to deploy a function. So let's see if that does it. All I'm doing here is triggering another script, which will create a function in my subscription ID. And once that's done, which I can just quickly show you what the function is doing. The script is doing, sorry, all it's doing is creating a function depending on the count. And once count is 1, it'll just create one app service plan storage account and function app. Interestingly, ngrok still doesn't seem to think that, unless I've done a mistake here. Topic. Event grid. Anyway, I'm going to leave that bit. But anyway, ngrok, we can actually get that. I'm going to share some more information about how that works in a blog post. It does trigger it, but doesn't hit for some reason. So I'm going to leave that bit. Or we can try it afterwards. Anyway, so that's the selected technologies. I hope it makes sense why we are selecting these technologies. First is Azure function. So the function is the bit which is going to do all the heavy work. It's going to figure out what to do, when to do, and then apply the changes. And event grid here is going to tell the function whenever a resource gets created or deleted. Oh, there you go. So this time the function has decided to, it took quite a while. Sorry for the interruption. It keeps on changing, isn't it? So the event grid has hit the function using ngrok this time. I'm going to stop this debugging now. Before I stop, I could quickly show you this bit actually. So if I get the data, this is the payload from Azure Event Grid, and I paste it in my files here. So if you see here, this has been triggered by a storage account. That's because, if you remember, my function here was creating a storage account. And when the storage account was being created, it triggered it. And I figured out why it didn't trigger previously, because in here, in filters, we said only when storage account is created or deleted. And that's why it did not trigger the debugging breakpoint. So at least now we know why it didn't. So now that we have got it, using this value, we can figure out what resource has changed where and possibly who has changed it as well. Because this will also give us, looking here, so in claims, it will also give us who is the user who is changing the resource. So we could gather all this information programmatically and use that in our allow listing system. Anyway, stop debugging, go back to the slides. So the last bit is resource group, resource graph explorer. So that's the one which is telling Azure function which IPs to allow and which IPs to go ahead and apply on Azure Event Grid. So Azure Cloud, I meant, sorry. So for the complexities, so this is just essentially the tip of the iceberg, because it does get even more complex than what it is. So we just discussed about Azure functions, but we should also be thinking about app services or web apps, because web apps can also have the same network restrictions on them, and they should, in theory, as well have it. But then what happens when virtual network integration comes in? Because once an app or a function app, a web app or a function app are virtual network integrated, they will have one IP. But then in the network restriction rules, it should be the VNet subnet ID that gets added, not the IP address. And whenever resource is deleted, we need to make sure any IPs for that resource get deleted as well. Because now in consumption plan, those IPs will be shared with another company, another resource. So we don't want those resources to have access to our Azure function. And that's why whenever resource gets deleted, we need to figure out how to remove those specific rules. The difficulty here is Resource Graph Explorer does not give you the details of a deleted resource. Once a resource is deleted, it can't tell you what were the IPs of that resource. So you do not, in theory, know what rules you should be removing once a resource is deleted. So it does get a bit more complicated. And along with that, recently we have figured, well, we are recently seeing this warning message actually, and Microsoft have updated their documentation saying there is a limit of 512 rules on any web app or Azure function. So the idea that we can go ahead and add as many rules as we wanted using that slightly dumb system of just picking up functions, IPs, ranges, add all of them, it is going to hit, or it has actually hit in our case many times, the limit of 512 rules. And currently it still works, but Microsoft documentation recommends not to keep hitting 512 rules because they are very likely going to restrict and stop any rules beyond 512 to take into effect. So with all those complexities in mind, this is roughly the current architecture of the solution that we are working with. So I don't think I need to go into details of this, but this is on the slide for you to have a look if you need it, if you want to check. But this is a solution which partly works and partly doesn't work. Well, not doesn't work. We need more integration tests to make sure we can cover all cases that we can think of. But management, the human management around those rules has reduced a lot. So we will be able to just create functions and trust the system to dynamically allow list certain IPs and rules and virtual networks. They'll be making it easier for us, hopefully. So in conclusion, security is quite a complex affair. And at NewDay, we take it seriously, meaning we have lots to do in this area. On top of that, implementing the least privilege principle is even more complex because it gets more and more difficult when you try to reduce the probability of somebody trying to access, trigger, or change anything in your ecosystem. And finally, cloud security is a shared responsibility. Microsoft are doing a lot, and I find Microsoft are quite good at what they're doing with Azure security. But on top of that, we need to be extra cautious because there's still cases where unwanted access can be enabled. So before we end, just quickly, a few extras that we have. One is there are a few blog posts. These two are blog posts about Azure Event Grid. So all the things that I demoed today, you should be able to access and see, understand in case you did not know before. Along with all the documentation that we saw will be on one of these actually blog posts. These are links to GitHub issues that we raised while working on this project. The system topic is still, well, I don't know how many bugs are still remaining, but there are a few bugs which Microsoft are fixing. One of the major ones that we have hit is that the secured event delivery to functions. So our functions are Azure AD. They need Azure AD authentication, and system topics cannot deliver events to a secured function. Custom topics can, but system topics fail to deliver because they are a global resource, meaning they don't have access to the Azure AD that we have enabled here. The solution at present, we are looking at putting a storage queue in between them. It gives more reliability as well as a better solution to the Azure AD authenticated function. But there are a few things that you may want to have a look in case you are thinking of a solution in these lines. The CIDR, which I touched on at the beginning of the talk, if you want to understand how CIDR notation works, go ahead to this blog post, and there is a video as well explaining how to do CIDR notations. That's all from me. So if there are any questions, please let me know.
Yeah, thank you very much. I don't see any question in the chat, but I'll give you some time to write some questions if you have any.
Yeah, Dushyant, a question on how is the service availability affected when you when you're reapplying all the rules?
No. So at present, no. So that's something. Sorry, is that the question, or have you got more?
Yes, I mean, just you were saying, there's a gap between the event grid triggering the new event and you doing the processing and then updating all the security to allow the links. So does that affect the application availability and stability?
So for event grid, that bit we haven't hit yet, but in theory it should affect. I think it will do, but we haven't hit it yet. But in the same time, when you apply rules, network rules, and they change, that should not affect your availability, because that's something I verified with Microsoft, and they said that if you are changing the configuration, that doesn't trigger a restart of the web app or function app. But the delay between an event triggering and our function triggering to do the rules, apply the rules, that in theory should cause a downtime, but we haven't hit that yet. So in theory, we can live with this solution until something better comes along.
Thank you.
No worries.
There's some feedback in the chat from Trevor saying that was great, really enjoyed it. I often wonder if we could dynamically update the IP restrictions. So yeah. Yeah.
Thank you very much. It's been a journey, because we have learned so many things about Azure and Microsoft in the meantime. Is there any other question? I had a quick one slide before I end.
Don't see any more questions, so I think I can just wrap it up. Yeah, you have
one more thing.
You have one more slide.
Yeah,
Go.
just quickly. So like we at NewDay, we are currently hiring. So this is the QR code. Feel free to scan it if you are looking, and apply for a vacancy if you do like it. So that's all from me. Thank you very much.